everybody, my name is Kai, this is Kai Likes Linux, and today we'll be talking about everything you need to know about the Linux operating system, down from the kernel up to the applications in a very basic manner. If you want to learn any more about this, feel free to Google whatever you wish, and be sure to remember that not everything you read on the internet is true, and sometimes people get things wrong. This is a very, very, very basic overview, basically telling you the basics of what every layer of the cake of an operating system does. So you start with the hardware, which we all know the hardware basically is the stuff that makes it the thing to go to do the beep boop thing. That's how you describe the hardware. And then you have the kernel. Now, a kernel basically does a lot of things. It gets the system information, the hardware information, tells applications where the hardware is, where it needs to go, and it basically works with the CPU and basically all the hardware, but mainly the CPU to tell your computer where things are supposed to go, what data they need, what is supposed to go where. Now, the kernel also boots your system to an extent. It has a very basic boot system called a bootloader. What a bootloader does is basically just start up the system and allow your system to start running in the first place. That bootloader is the most important part of a kernel, and even with like the extra hardware stuff, you can write a very bare bones kernel without any of that extra crap, but you cannot write a kernel you can write a very, very bare bones kernel without needing like extra hardware, including keyboards. It wouldn't be a very useful operating system, but it's still an operating system with a kernel. But the bootloader is the most important part of the kernel, and if you want to learn more about bootloaders, I recommend you go look it up yourself, because they're very fascinating and not something we can do a very deep dive basics into, if we're just keeping this into a short tech quickie like style video, but with a little bit more rambling. But the next layer is the operating system itself. Now, the operating system has core utils, an init system, and basically any other applications you have, including your desktop environment, window manager, and whatever. Now, the important part to note is the operating system itself starts with the init system, like systemd, OpenRC, and a BSD init if you're using BSD. But they're not all equal, and I do not have enough information myself to say which one's better, which one's worse. But the most popular is systemd, but systemd is also arguably one of the most hated init systems out there. So, you win some, you lose some. The init system, in short, basically initializes everything, starts talking to the kernel, and starts connecting the applications to the kernel. Basically, it's the layer between the kernel and the operating system itself. And the reason that has to exist is because the kernel can't do everything, and sometimes some things just don't work if you don't have a layer to talk to the kernel and the operating system. Because the operating system needs to talk to the kernel, it basically, and the init system is that way to better talk to the kernel without having to write a bajillion lines of code into your operating system and hope it works. However, systemd has become that bajillion lines of code, so whatever. So the next layer up is the core utilities, which is your shell, your bare bones basic commands, things that basically give you the ability to use your computer very bare bonesly. All you really need is up to this core utils point to have a usable operating system. However, it's probably not for the best because you still need a bunch of other applications to make sure it works better. Because not always included are the zip. Depending on what core utility set you use, it won't always include like a zip file manager, tar manager, and it should theoretically include a C compiler, but not all of them do. And that's usually a problem because if you don't have a C compiler, that's a big, big problem for many people. But, whatever. That C compiler is probably the most important part because a lot of applications, to get other applications easier, is written in C. So hopefully that works well. I'm pretty sure GNU Make is also technically a core util. There's a bunch of applications within that core utility set, but not all of them have to be included necessarily, except for the shell. There's no such thing as an operating system without a shell. And don't give me, oh, but macOS and Windows don't have a shell. They do have a shell. Actually, Windows has two. Windows is so bad they have to have two different kinds of shells. The command prompt, CMD, or terminal interface, and the PowerShell terminal interface, which is terrible. And of course, macOS has a shell because it runs on the XNU kernel, which is, I think, at least partial fork of Darwin, which is a partial fork of BSD in Unix. So macOS is a descendant of Unix, basically. And that's what I'm going to say, because I'm not 100% sure if it's BSD, but I'm 100% sure it's a derivative of Unix eventually, at least. But the next part is the actual operating system. Now, the rest of the operating system, basically. Your applications, your display manager, everything. Let's start with Xorg, Wayland, and Arcan. So basically, these things are written these don't use anything like GTK or Qt. These things are not written in a normal graphics library. I wouldn't say 100% of the time, because they're supposed to manage those graphics libraries no matter what. Like, they manage GTK, they manage Qt, they manage FLTK, they manage ncurses. These things basically give you the ability to manage your displays. And Xorg is the oldest and most popular one to date. However, it's slowly being replaced by Wayland. Wayland, in short, basically makes less assumptions about what the device is running on, and leaving it more up to the compositor and streamlining the whole system. While X is just really old, has tons of legacy code, and not really made for touch screen stuff. And there's also Arcan, and by the way, I'm actually going to link the person who told me what the differences between these are, because this person, without this, I wouldn't have this explanation. Arcan is unique. It bleeds more into DE desktop environment territory, as DEs are made using Lua. Not all of them, but okay. And it has global buffers for most windows, allowing insane shenanigans and like zoomable user interfaces and putting window contents in other windows. And hopefully soon there will be Stardust, which plays more into DE territory, but is more XR optimized using Wayland for 2D capability and such. Now, we're going to get into what a DE/desktop environment is in a bit. But first off, I do want to correct what they said. No, not every DE is made in Lua. Most of them are actually made in C or C++, or even Vala. Maybe Arcan is using Lua, but as I read it, they said DEs are made using Lua, so you know what, whatever. But that aside, basically what these things do is a bunch of different things to basically talk to the system in its system, to talk to the desktop, to talk to the hardware, to basically give you your graphical environment. Windows has one, but I don't remember what they call it. I know what they call their kernel. It's the NT kernel, and I don't know what macOS uses anymore. I forget what they called that, but I know what the kernel is XNU. But they basically talk to those systems to get a graphical display open that basically gives you a dock and everything. Well, not everything. That's not up to that display system. That's not up to that. The next layer up is the display manager / login manager, as more or less they kind of intertwine. And there's a bunch of different options. The more popular three are GDM, SDDM, Simple Display Manager, SDDM, Simple D Display Manager, I forget what the other D was called, and there's Light DM, which is made by Canonical, and is used even though Canonical doesn't use it. As far as I can tell, at least, it's made by Canonical because I found it on their GitHub. I could be wrong about them using it, though. Making it, though. But LightDM is probably the most popular one to put in an operating system. It's become so popular, it's boring. GDM is the second most popular, and SDDM is arguably the third most popular. I know because if you're not using LightDM or GDM, you're probably using SDDM, which is perfectly fine. What these things do is basically manages your display. And the reason why they're also partially login managers is because they've all basically decided that the display manager can be, like, you manage your displays through a login manager. So when you're logging into a Linux system, you can change your desktop environment and basically manage your displays from the login manager and then log in from there. Once you log in, you have one of two things: a window manager or desktop environment, at least if you're using a graphical interface. If you're not using a graphical interface, you're more or less using a terminal, which means you're not at this point, and that we can ignore that for now. Now, the display manager, when logging in, lets you select a one of how many desktop environments you have installed. Now, this includes XFCE, LXQT, LXDE, KDE. There's a lot of ones with weirdly acronym titles for some reason. I don't know why. There's GNOME, there's a bunch of other popular desktop environments. Now, what the desktop environment what you have is part of a window manager. In a desktop environment, you have a couple things. You have a window manager, volume manager, and a bunch of other applications that basically run in the background of the desktop environment to basically, like, if you want to turn up your volume by hitting buttons on your keyboard, you do that through the desktop environment. Now, if you don't have a desktop environment, you're more or less likely to either have a terminal interface, and that's it, or alternatively a window manager, which is more popular for graphical users instead of like a terminal that looks like a graphical interface for a lot of good reasons. Now, what this interface can do is basically not what the window manager the desktop environment can do. Your desktop environment more or less always includes a dock. It always includes like desktop applications, like desktop folders, a search function, an application searcher, your volume, basically everything like Windows 10 can do, it can do that. But a window manager just takes one part of that and runs with it. Some of them do have stuff like, I know Flexbox has a dock, very bare bones dock, and most other window managers have very basic things like a little title, like a top bar, a bottom bar, that basically tell you basic system information, or displays and all that, and basically give you the basics of your system. Now, the window manager is much more bare bones, and you basically open up applications with it. While a lot less usable for many beginning users, it's actually a lot more lightweight, making your system a lot easier to work with. I actually, when I had a much worse computer, I always had when opening a virtual machine, I switched over to my window manager, which at the time was OpenBox, and just use that for my virtual machine because they're so light. Now, both desktop environments and window managers are written in a graphical library. How many graphical libraries are there? Too many to list, but let's name some of the more popular ones and my favorite. The GTK, Qt, FLTK, Ncurses, technically. What else? There's probably a billion others that are out there too, but those are the ones I can name off the top of my head, as well as VUI, which is not currently in a desktop environment yet, but it's relatively good enough to do bare bones work with. It can do basically everything a desktop environment can do, but to a lot lesser extent currently, because everything to do with V is early access. But let's not worry about that. We'll worry about that in another time. when I explain V in my own video, a tutorial on V actually, which will be running a graphical, which is going to be making a graphical interface thing with VUI, but that will be a tutorial for another day. Be subscribed and like for that. But basically, what these graphical libraries do is give you the graphics. Each one has their own pros and cons. Each one is different. If you want to know the differences, basically look into them yourself. But in the end, the real main thing you need to worry about is theming mixing, because GTK applications do not mix well with Qt application theming. And that's pretty much the biggest thing you need to worry about. Otherwise, the differences aren't incredibly important unless you really care about the differences between OpenGL and Vulkan, but most people don't. And if you do care about that, look into that yourself. It's really not a big deal. OpenGL is just slightly slower, and I think GTK4 is switching to OpenGL, while Qt6 is switching to Vulkan. Maybe it's vice versa. I don't know. But that's really the only real difference, and it doesn't really matter to most people. The real difference is theming, and you can, in fact, make a theming application that works for both. So, whatever. And then you finally have your applications. The most important one being your package manager, your package installer application, and web browser, terminal, emulator, etc., etc., etc. These are basically applications that let you use your computer. The terminal emulator is basically what lets you use the shell. It's basically like cmd.exe or the PowerShell application on Windows, and I think macOS also has their own terminal as well. And it basically gives you a little window with a little terminal interface that lets you install packages, manage your core utils, build applications, yada, 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 yada. And that is a very, very... I try to keep this as short as possible, even trying to limit this. But this was my very quick deep dive into operating system basics. And hopefully you like this. I know this wasn't my most high quality video, but this was something I wanted to do, especially with it being requested. And so, hopefully you like this. Have a wonderful day, everybody. And I will see you in the next video. Bye-bye.